Okay, the final endpoint that we are going to build out for our blockchain API in this section is our mine endpoint, which will mine and create a new block. So in order to create a new block, we are going to use our create new block method. So let's do that now. So inside of our endpoint, we will say const new block equals Bitcoin dot create new block. Cool. So this create new block method takes in 3 parameters: a nonce, a previous block hash, and a hash. So we're also going to have to do calculations to get all 3 pieces of this data that we need. So let's do that now. Let's start by getting the previous block so we can get its hash. So up here, we will say const last block, which is the last block in our chain, or the previous block to our new block. So we will say const last block equals Bitcoin dot get last block, which is the method that we created right here. Cool. And we want to get the hash value off of this last block. We want to get this last block's hash. So underneath here, we will say const previous block hash equals last block at the hash property. Cool. So now we have our previous block hash, which is one of the parameters that we needed for our create new block method. Next, let's get our nonce. So in order to produce a nonce for our block, we need to do a proof of work. So let's do that now. In our endpoint, we will say const nonce equals Bitcoin dot proof of work. And I just want to make it clear that from our proof of work method, we will get a nonce returned to us. So we're saving that as our nonce variable. Now our proof of work method takes in 2 parameters: a previous block hash, which we already have, and current block data. So let's define our current block data right now. So we will say const current block data equals an object that will represent our data. And this data will simply consist of the transactions in this block, which will be Bitcoin.pending pending transactions. And there will also be an index that we will put into our data, which is the index of this new block that we're going to create, which will be our last block, this variable, at position index, or excuse me, at property index plus 1. Cool. So this object right here is what will comprise our current block data. It's simply going to be the transactions that are present in this new block and the index of this new block. And you could add other data into here if you wanted to, but for our purposes, this will work just fine. Cool. So now we can calculate our nonce. So our proof of work takes in our previous block hash and our current block data as parameters. And with this calculation, we should now have a nonce. And the final parameter that our create new block method has to take in is a hash of this new block. So let's calculate that now. To create a hash of this new block, we are going to use our hash block method. So we will say Bitcoin.hashBlock. and we will save the result as a variable called block hash. Okay, cool. So let's check out this hash block method, which is right here. And it takes in a previous block hash, which we have, current block data, and notes. And we have all three of these, which is good. So we will pass in our previous block hash, our current block data, and our notes. Perfect. We now have all of the parameters that we need to run our create new block method. So let's pass them in. We have the notes that we need, the previous block hash that we need, and the current block's hash. Cool. Perfect. So now, from this method, we should be creating a new block. Cool. Now, this is pretty awesome what's happening here. What we're doing is we're mining a new block by using a proof of work. And as you can see, there are a lot of different calculations that go into creating this new block. And we are able to make all of these calculations by using our blockchain data structure. So it's a pretty powerful data structure, which is pretty cool. And our blockchain can now mine new blocks by using a proof of work, similar to how many other blockchains function as well. So it's pretty awesome. So at this point, we have created our new block, and all we really have left to do is send a response back to whoever mined this block. So we will say res.json, and we will simply send back a note that says new block mined successfully. And we will send back the new block by saying block is new block. And by sending back this new block, it's not going to affect our blockchain in any way. This is just so that the person who created or mined this new block knows what it looks like. Cool. Now, there is one thing left that we have to do. So every time that somebody mines a new block, they get a reward for creating that new block. So what we have to do is make a transaction and send the person who mined this new block a little bit of Bitcoin as their reward. So right here, we're simply going to make a new transaction by saying bitcoin.create new transaction. And currently in 2018, in the real Bitcoin blockchain, there is a 12.5 Bitcoin reward for mining a new block. So just to stay consistent with the real Bitcoin, we're going to make our reward 12.5 Bitcoin too. So we're going to put the amount of this transaction as 12.5 Bitcoin. And as a sender address, we're just going to put the value 00. This way, whenever we are looking at transactions on our network, we know that if a transaction is made from the address 00, that it is a mining reward. Cool. Now all we need is a recipient's address. We need to send this 12.5 Bitcoin to whoever it is that mined it. So who are we going to be sending this 12.5 Bitcoin to? Well, we're going to be sending this reward to this current node that we are on. So if you look at this whole file, we can treat this entire API as a network node in the Bitcoin blockchain. So we want to send this 12.5 Bitcoin to this network node. In future sections of this course, we are going to have multiple instances of our API, and they are going to act as different network nodes in the Bitcoin blockchain. So right now, whenever we hit any of these endpoints, we are always only communicating with this one network node. But as we know, all blockchain technology is decentralized and hosted across many, many different network nodes. So in future lessons in this course, we are going to be creating more network nodes. But for right now, our entire blockchain is hosted solely on this one network node. So anytime we hit this mine endpoint, we want to reward this node for mining the new block. Cool. So in order to give this node the 12.5 Bitcoin reward that it deserves, we need an address to send the Bitcoin to. So let's create an address now for this node. In order to create an address for this node, we are going to import a new library called UUID. So in our terminal, we can say npm I UUID -- save. Cool. And let's start our server again. Good. Now we want to import our new library by saying const UUID equals require UUID / version 1, which is version 1 of this library. Now basically, all this library does for us is it creates a unique string, a unique random string for us. And we're going to use that string as this network node's address. Simple enough. So we're going to say const node address equals UUID invoked. And one thing that we want to alter about the string that we get from this library is that in this string, there are going to be a couple of dashes present. And we don't want any dashes in our address. So what we're going to do is we're simply going to say UUID.split that string on all of the dashes and then rejoin it with an empty string passed in. Cool. So all this is doing is generating a random string for us that is guaranteed to be unique to a very high percentage. We really want this string to be unique because we don't want to have two nodes with the same address. Otherwise, we'd end up sending Bitcoin to the wrong people, and that wouldn't be good. So we have a unique string here, and we're simply just taking the dashes out of it. And that's what we're going to use as our node address. Cool. Now we can simply pass this node address variable into our create new transaction method. So we will say node address right here. Perfect. And that's it. So to run through our mine endpoint one more time from top to bottom, basically what we are doing is performing a proof of work so that we can create a new block. And all of this information up here is necessary to do our proof of work and create a new block. We are also creating a new transaction, which is a mining reward that we are sending to this network node, which is this instance of our API. And then we are simply sending back a note that says the block was mined successfully, and we are sending back what the new block looks like. Cool. Now, I just want to mention that if you're a little bit confused about this whole network node thing that I've been talking about and why we have a node address for our API, don't worry. In the next section, we are going to be creating a network that will host our blockchain across many different nodes or many different copies or instances of our API. So this whole network node thing should become a lot more clear. Cool. In the next section, we will test our mine endpoint along with our transaction endpoint and blockchain endpoint to make sure that they all work correctly and make sure that they all interact correctly. I'll see you there.